All right, today we're going to pull back the ceiling tiles and take a look at the hidden science that keeps our modern buildings up and running. It's this invisible system that, believe it or not, dictates how comfortable we are, eats up a massive amount of energy, and it's in the middle of a quiet revolution. So let's dive right in.
You know the feeling, right? We've all been there. One person in the office is sweating. The person next to them is freezing. You're in this constant battle with the thermostat, but it just seems to do whatever it wants. It's something we all complain about. But what if I told you it's not just a minor annoyance? It's actually a symptom of a much, much bigger and more wasteful problem.
Yeah, that discomfort you feel? It's a bright, flashing sign of massive inefficiency. And when you zoom out and add it all up, buildings account for a staggering 40% of our total energy use. And a huge chunk of that is just gone, wasted, literally thrown away by systems that are basically fighting with themselves. The stakes here are incredibly high.
So where's all this waste coming from? Well, the culprit is usually hiding right above our heads in our HVAC systems. That's the heating, ventilation, and air conditioning. For decades, we've just been designing them based on these really outdated assumptions. But now, a new wave of research is completely flipping the script.
So what's the engine behind this revolution? It's something called ASHRAE Guideline 36. Now I know, that sounds super technical and maybe a little boring, right? But stick with me. The best way to think of it is like a smart operating system, an OS, for your building's HVAC. It's basically a pre-written, expert-level program that tells all the different parts how to work together in perfect harmony.
To really get why this is such a game changer, you have to see the before and after. The old way, it was total chaos. Every single building's control software was a custom, one-off job. It was expensive, unreliable, and usually full of bugs. Guideline 36, or G36 as we'll call it, changes all that. It's a standardized, plug-and-play playbook that guarantees you get high performance right out of the box.
And the process now is just so much smarter. You've got the world's top experts at ASHRAE creating these perfect, smart sequences. Then, the companies that actually make the equipment just bake those instructions right into the hardware. So an engineer no longer has to write thousands of lines of code. They just specify one thing: use Guideline 36. And boom, just like that, the building has elite-level intelligence built right in.
Okay, so we've got this smart OS, but what does it actually do? Well, one of the biggest things it does is completely bust a myth that's been at the heart of HVAC design for decades, and that's the myth of minimum airflow. We've always had this gut feeling that pumping more air into a room is better, right? More fresh air, more comfort, but it turns out the exact opposite might be true.
And this is where it gets really wild. This isn't just a theory. A huge study went into real, actual buildings and just asked people, "Are you comfortable?" And the results were shocking. Look at this chart. In every single case, the buildings that were running with less minimum airflow had fewer unhappy people. They were literally more comfortable with less air. This one finding turned decades of conventional wisdom completely upside down.
So that begs the question, right? Why on earth were we using so much air in the first place? Well, the study found that the VAV boxes, those are the little dampers that control airflow into each room, are typically installed to be about 3 times larger than they need to be. 3 times! This massive oversizing forces the system to blast way too much air, even when it's on its so-called minimum setting.
And this is where the absurd energy waste happens. With the old logic, that oversized box dumps way too much cold air into a room. The room gets too cold, so what does the system do? It kicks on a reheat coil, basically an electric heater, to warm up the air it just spent a ton of money cooling down. It is exactly like driving your car with one foot on the gas and the other on the brake. It's insane. The G36 logic is way smarter. It delivers only the tiny bit of cool air that's actually needed, so it never has to do that wasteful reheating.
This smarter approach has a cool name: Dual Maximum VAV Logic. It's one of the secret weapons inside Guideline 36. And all it really means is, instead of a dumb, fixed minimum airflow, the system is smart enough to let the airflow drop way, way down to what's truly needed for ventilation. The amount of energy you save on fans and heating is just enormous.
But, this whole revolution isn't just about software. G36 is designed to work hand in hand with smarter hardware. The physical nuts and bolts of the HVAC system are getting a major upgrade too, letting us build systems that are more efficient, more reliable, and even quieter.
Okay, let's talk about the fans. For years, buildings used one single giant fan.
This created a huge risk, right? If that one fan failed, the whole building's ventilation system went down. The new approach is the fan array. Think of it as a coordinated team of smaller, smarter fans all working together.
And the advantages here are huge. If one of the small fans in the team fails, the others just speed up a tiny bit to compensate. Nobody even notices. They're also much quieter, and replacing a small fan is a simple one-person job. This design is what allows for these massive, ultra-efficient, mega air handling units in really big buildings.
This new intelligence even extends to the ductwork, all that sheet metal above the ceiling. The old ways of sizing ducts were really complicated and often led to systems that were way too big and expensive. The new philosophy? It can be summed up with a simple, memorable mantra: start fast, end slow.
The official engineering term is the friction rate reduction method, but what it really means is you use smaller ducts and higher air speeds right near the fan where there's a lot of pressure. Then, as you get further down the line, you gradually make the ducts bigger and let the air slow down. It's an elegant approach that saves a ton of money on materials up front and helps the whole system fit into tighter spaces.
So let's put it all together. You combine the smart software from Guideline 36 with smarter hardware like fan arrays and this better duct design. What's the ultimate payoff? Well, the answer is simple. Everyone wins.
Seriously, look at this. Building owners get lower construction costs and smaller energy bills for the entire life of the building. Engineers and contractors get a simpler, much more reliable design process. And us, the people actually working in the buildings, we finally get to be consistently comfortable. Oh, and of course the planet wins, because we stop wasting just enormous amounts of energy for no good reason.
So here's the key takeaway. This isn't just about a few minor technical tweaks. It's about fundamentally rethinking the invisible systems that surround us every day. By looking at everything from the software logic to the physical hardware, we are creating buildings that are cheaper, more comfortable, and way, way better for the planet.
You know, this whole revolution in building science really shows what's possible when we're willing to challenge old assumptions and apply new intelligence to systems we just take for granted. And it kind of makes you wonder, doesn't it? What other invisible systems that run our world are just waiting for their own quiet revolution?